Assalamualaikum and very good day to our lecturer Prof. Tanabale. We are from Group 4 presenting Industrial Effluent and Wastewater Residue Project, specifically for dye or pigment manufacturing industry. This is our team members, Luqman Hakim bin Muhammad Noor, Muhammad Syafiq bin Muhammad Yusof, Siti Nur Safiha binti Suhaimi, Muhammad Fikri bin Nazri, Nur Hikmah binti Zulkifli, and lastly Muhammad Amir Arif bin Muhammad Amiruddin. This is the outline of our presentation. We will start with introduction, process detail, identification and classification of effluent. We will proceed with law and regulation, proposed treatment effluent treatment system, design of any unit, and lastly we will end with conclusion.
Assalamualaikum and a very good day. My name is Luqman Hakim and I will start this presentation with the introduction part. So what is meant by dyes? Dyes can be defined as a colored substance that chemically bonds to the substrate to which it's being applied. Dyes are categorized based on their use and chemical composition that are made up of a group of atoms called chromophores, which are responsible for the dye's color. These chromophore containing centers are made up of azo, anthraquinone, methane, nitro, arimethane, carbonate, and other functional groups. The details of the process will be explained later by my friend. Textile, pharmaceutical, food, cosmetic, plastic, and paper industries all use certain substance with significant coloring potential. This shows that the usage of dyes is very frequent in any industry to get the product they want. Statistics also prove that over 10,000 different dyes and pigments are estimated to be used in industry with over 700,000 tons of synthetic dyes manufactured annually. Therefore, all industries should be responsible for the use of dyes because if they are not treated and disposed of properly, it will adversely affect the environment. For your information, our project is mainly focusing on textile dyes industry because this industry use more dyes compared to others. I think that's all from me and I will pass the floor to my friends to explain about the process of dyeing textile.
Assalamualaikum, I'm Sabiha. I will continue about the process details of the textile dyeing. The dyeing process can be accomplished by the continuous process or batch process. Batch process is typically used in the worldwide, since the dye is progressively transferred from the dye bath to the material being dyed or over a relatively long period of the time in batch processing. The dyeing takes place in the presence of the dilute chemicals in a closed equipment. The fabric in the batch process stays in a single piece of equipment that is alternately filled with water and then drained at the stage of the process. While for the fabric in the continuous process is being moved through the different baths in a long series of equipment parts. The fabric uses 5 to 10 times its own weight in water each time it is exposed to a separate bath when undergo the continuous process. Next is the process involved in the textile dyeing. So the first step is preparation, and then dyeing process, and lastly finishing process. So preparation is the process of removing unnecessary impurities from fabrics prior to dyeing. Cleaning can be done in this step with aqueous alkaline substances and detergents or enzymes. Bleaching also is done in this process, which bleaching is an important process in this step after the cleaning process. There are three technologies used in bleaching, which is the sodium hypochlorite bleaching, hydrogen peroxide bleaching, and sodium chloride bleaching. The standard chlorine dioxide concentration in bleaching effluent is 10 to 200 mg per liter. Second step is dyeing. Dyeing is the aqueous application of color to textile substrates, primarily with synthetic organic dyes and in some cases at high temperatures and pressures. Surfactants, acids or alkali, electrolytes carriers are used in this step. These kind of chemical aids are added to the textile in order to achieve uniform depth of color with the color fastness properties appropriate for the fabric's intended use. Diffusion of the dye into the liquid phase, adsorption onto the outer surface of the fibers, and finally the diffusion and adsorption on the inner surface of the fibers are all included in the dyeing process. Last step is finishing. Finishing is a process that uses chemical compounds to improve the fabric's consistency. Fabric treatments used in the finishing process include the permanent press treatment, waterproofing, softening, anti-static protection, soil resistant, or microbial and fungal protection.
My name is Nohikma binti Zulkifli with Metric ID 24451 and I will be present about the effluent identification and classification. The effluent discharged from the textile processing are a mixture of dyes, metal and other pollutants. The dyes can be categorized into natural and synthetic dyes. The synthetic dyes have a long-lasting color and wide range of color choices, which makes them more widely used than natural dyes. Synthetic dyes are classified into two different groups according to their chemical and according to their mode of the application. Most of the textile dyes industry use azo dyes for the dyeing process. In fact, azo dyes account for approximately 60 to 70% of all dye used in textile manufacture because of its ability to supply complete rainbow of color. The dye effluent are high in the color, pH, suspended solid, chemical oxygen demand, and biochemical oxygen demand, as stated in this table. In addition, metals and salt also present in the dye effluent. Textile process where they actually have includes dry and wet processes. In the wet process, where they utilize a considerable quantity of potable water and release highly contaminated wastewater. For example, we can see here in this table, the total dissolved solid is quite hard from 2,900 mg per liter to 3,100 mg per liter. In fact, the permissible limit for the total dissolved solid in textile effluent is only 500 to 2,000 mg per liter. Therefore, during the treatment process, it is vital to monitor and compare this parameter with the standard concentration before discharge the corresponding effluent to the receiving water body.
Hi, my name is Muhammad Amir Arif. Now I will explain about law and regulation. In Malaysia, there are specific standard limitations that industry need to follow in order to release their effluent. To enforce this and prevent the environmental pollution, legislation and environmental bodies such as DOE has come up with Environmental Quality Act EQA 1974. So what is EQA 1974? It is an act makes provision and prevention, abatement, control of pollution and enhancement of the environment. So for industry to release their effluent discharge in this EQA, it divided into two parts, which is Standard A and also Standard B. Standard A is for upstream release and Standard B is for downstream release. This act is also to prevent the environmental disaster that will affecting the surrounding society and also surrounding wildlife. So one of the example of environmental disaster is the Kim River in 2009 incident where the illegal dumping of toxic release that affecting 6,000 people surrounding and hospitalizing 2,775 people. This is National Water Quality Standard for Malaysia that mentioned in the EQA 1974. In this National Water Quality Standard, it mentioned the maximum amount of contaminant released in the industry effluent for both Standard A and also Standard B. For dye or pigment manufacturing industry, the parameter that need take into account is the temperature, pH value, BOD5, COD, suspended solid, color and also turbidity.
Hello, my name is Muhammad Fikri and now I will talk about the proposed effluent treatment system. This is the wastewater treatment system. There are 7 types of proposed effluent treatment system for this case study. Firstly is bus screening. Bus screening is the part of the primary filtration and it removes a large item from the effluent. Next, for the screening is the process of removal of grit in the effluent. It is also to prevent damage to the pump and equipment. Next is the primary clarifier. It acts as the initial separation of solid organic matter and it also allows the heavy solid to sink at the bottom of the clarifier. After that, we go to the aeration. It's the process
to pump oxygen to the tank. This will encourage the breakdown of organic material. And now we go to secondary clarifier. This is to allow any remaining organic sediment to settle out. It's also to activate sludge and it will sink, the activated sludge will sink to the bottom of the tank. And lastly, for the chlorination, it functions to kill any remaining bacteria in contact chamber. This is also due to the enhanced oxidation of bacteria from the aeration stage. From the proposed effluent treatment system, the one that we are focusing on for the design unit are the secondary clarifier. This is an example of the secondary clarifier. After the effluent flows out of the aeration, it will flow into the secondary clarifier. The treated wastewater is pumped into the secondary clarifier from the aeration tank. The function is to allow any remaining organic sediment to settle out of the treated water flow. This is being done by any small solid will sink to the bottom of the tank. The small solid is also known as the activated sludge and consists mostly of the active bacteria. However, some part of the activated sludge is returned to the aeration tank. Okay, that is all from me. Thank you.
Hi, I'm Shafiq. I'm presenting on the secondary clarifier, which is the proposed design unit. So secondary clarifier act to separate the biomass generated during the secondary treatment process from treated plant effluent. Generally, clarifier consists of two functional zones, which are clarification zone and thickening zone. There are four major factors that need to be considered before designing a secondary clarifier, which are location, the shape of the clarifier, which is rectangular or circular, and then we have the specification of secondary clarifier, which consists of the volume, diameter, depth, and last but not least, we have the feature incorporated in the design. So the first factor considered in designing of secondary clarifier is the location. So the location of the secondary clarifier should be near the treatment facility and near the aeration tank or basin. So the benefit of strategizing this equipment location is it will have cause the reduce of operating costs in transferring of the wastewater. It will improve the flow of material, and lastly, it will have higher utilization of space and equipment. We move on to the next factor, which is the shape. So for clarifier, there are two shapes available, which are rectangular and circular. Circular has been chosen for secondary clarifier as it will have shorter detention time for settling sludge, easier to accommodate in-tank flow collection chamber, low maintenance, and lastly, it's easier to remove heavy sludge. So the downside of using circular clarifier is it will have higher short circuiting potential and it will have higher flow distribution head loss. We move on to the next specification of the secondary clarifier, which consists of the area, the diameter, the depth, the volume, and the inlet of the secondary clarifier consists of the feed well diameter and feed well depth. So the calculation for the specification will be based on the formula, and for the design specification will be based from the literature review, where the volumetric flow rate of 380 meter cube per day, SLR, which is the surface loading rate of 22.8 meter cube per meter square day, ratio of diameter over depth is equal to 6. So the calculated specification are the area of 16.67 meter square, the diameter of 4.08 meter, the depth of 0.68 meter, the volume is equal to 8.89 meter cube, and then for the inlet we have the feed well diameter of 0.612 meter, and lastly we have the feed well depth of 0.204 meter. And we move on to the last factor, which is the features incorporated in the design. So the first features we have the spiral scraper, next we have the flow control, foam control, chemical addition, and lastly we have the length of wear.
Alright, so now we have come to the end of this presentation. What can we conclude here is textile dyes industries are undoubtedly large water consumers and thus produce large amount of wastewater with characteristics that are environmentally harmful. Before considering treatment methods to curb the negative effect of textile dyes wastewater, the issue should be solved by executing prevention plans of wastewater pollution. This can be done by efficiently controlling the water consumption and product wastage in the textile dye processing plant. All industries also should follow the law and regulation limits so that it won't affect our environment. The design proposed earlier also is very important for the treatment of textile wastewater so that clean water can be produced. Last but not least, textile dye industry should be aware of their prevention methods and treatment methods to reduce the harmful effect of the environment by giving importance to this implementation as much as they prioritize production method. I think that's all from us, and remember that a beautiful environment starts with you. Thank you.
That's all for our presentation. Thank you.